Hey everyone, we're going to look at the first three questions in section 2.4 homework and achieve 1, 2, and 3. They're all sort of choose or just choose the option basically. I will also say this on some of these problems, the graph when I first opened this up didn't show up. It took a long time to show up. Actually, on question 2, I had to close out and reopen the assignment. So just if it says, look at the graph and you don't see a graph, give it a few moments, see if it loads up. If not, you might need to close it out and reopen it and see if that does it. Any rate, consider the graph of this piecewise function, state whether the function shown in the figure is left continuous only, right continuous only, or discontinuous at the point x equal 1. Okay, so this is question number 1 again. Obviously, it's not continuous at 1 because we see a clear break in the graph, right? The limit doesn't exist. The limit from the right appears to be 2. The limit from the left appears to be something greater than 3. Since those one-sided limits are not equal, it's clearly not continuous. It's discontinuous. But is it right continuous or left continuous? There, that's a possibility. It's kind of hard to see this. I'm using Mozilla Firefox. I don't know what you use for your browser, but there should be a way to maybe zoom in a little bit and you can maybe see. It's kind of hard, but this is an open circle here at 1. This is a filled in circle. So the value of the function at 1 appears to be, something like 3.1 or something, just a little bit more than 3, right where that point is. Now, notice the limit from the right as we approach from the positive side is going towards this hole, right? So the limit from the right is equal to, looks like about 2, right? We're going towards 2. The limit from the left is going to this point here, which has a y coordinate again of about 3.1. So the limit from the left equals the value of the function, and therefore that is by definition what we mean by left continuous. So if the limit from the left is equal to the value of the function, then it's left continuous. If the limit from the right is equal to the value of the function, then it's right continuous. If both of those things are true, then the function would actually have to be continuous, right? So we know they both can't be true in this case because we know it is discontinuous at 1. So obviously, the only thing we can say, it is left continuous only. Let me zoom back out and we'll do left continuous only. We'll check our answer. And we'll go to the next question. Oh, and here it is. It's not showing the graph. Let's see. I might have to close out. Let me see if this is the problem that I had. Did it again. I'm going to do refresh. There it is. So you just play around with it, refresh, give it time. Maybe I wasn't giving it enough time. Okay, so number 2, consider this graph of this function. You can see it a little bit better. Find the point C at which the function has a jump discontinuity, but is left continuous. Okay, so jump discontinuity is where we have a break in the graph. We have a jump discontinuity at 1, and we have jump discontinuity at 5. Not at 3. It's discontinuous at 3, but it's not a jump discontinuity because the limit actually exists, right? The limit from the left and the limit from the right both exist and are equal to the y coordinate of this hole right up here. Okay, even though the value of the function is not that, it's discontinuous, but the limit, it does exist. Here, the limit does exist, and the limit from the left is, looks like 2. The limit from the right looks to be about 3 at 1. So the limit itself does not exist, but we have a jump discontinuity. But notice at 1, it is left continuous because the limit from the left equals the value of the function, right? F of 1 is 2, and the limit from the left is 2. At 5, f of 5 is equal to what looks like about 1 here, the height of this point, but the limit from the left, as we get closer and closer to 5 from the negative side, we're approaching this hole, which has a y coordinate 4, it looks like. So the limit from the left is 4, the value of the function is 5, so it's not left continuous at 5. So the value of C is going to be 1, right? Where C equals 1 is where we have jump discontinuity, but it is left continuous. What value should be assigned to f of C? So what should the output of f of C be to make f right continuous at x equals C? Okay, so now we say C is 1. So we're not right continuous because as we approach 1 from the positive side or from the right, we're going to what? The y coordinate of this hole, which is about 3. So the limit from the right is 3, but f of 1 is 2. In order for it to be right continuous, we would need f of 1 to be equal to 3. We would have to, basically take that point and move it up here. So fill in this point and leave that as a hole down there. So in that case, that's what we would have to do to make it right continuous. So we need f of 1 to be equal to 3 for it to be right continuous. Okay, so let's just make sure I did that right. Oh, good. I'm so glad. Let's look at the next question. Again, this graph, very similar to the one we looked at in number 1. At which value of x is the function left continuous only? It looks like the same question that we had up here. Okay, maybe I'm I'm just doing these things so much, it seems like the same problem. So at what value is x the function left continuous only? Okay, so it's left continuous anywhere it's continuous, but it's also right continuous there. So we don't want it to be right continuous. Notice at 3, we are both left and right continuous, right? Both from limit from the left and limit from the right, both exist. I'm sorry, I just said something wrong. Completely forget that. It's not left continuous or right continuous. It's discontinuous at 3. I'm sorry. The limit from the left and the limit from the right both exist, but are not equal to the point. So it's neither left continuous nor right continuous at 3. Woo, okay. At 5, we are right continuous, right? Because the limit from the right is going to be whatever the y coordinate of that point is, which is about 1.9 or 1.8, whatever. And that's the value of the function. So the limit from the right equals the value of the point, right? We're going right to that point. From the left, we're going to this hole, right? So the limit from the left is something like 3 point something. It is not equal to the value of the function. So we're right continuous, but not left continuous. We want this to be left continuous only. That's going to occur at 1, right? The function is left continuous, right? Because the limit from the left equals the value of the function. The limit from the right does not. So it's not right continuous. So the answer should be x equal 1. Okay. All right, that can be a little confusing, especially if you have trouble with your, which way is left and which way is right. Remember, left is below or from the negative side, right is above or from the positive side. Okay, let me know if you have questions about this.